All right, excellent. I think everything's right. Cool. So, got this back in it. I just need to increase my monitoring. There we go. Right. So last time we went over going from textual. Oh, it's over here. Standard text descriptions of how to do things, how stuff works. I mean, I'll come up with some more detailed aspects of this and probably another time. But for now, my intention is to go from this UML we've made and at least put these in as implementable classes inside the Armor engine. So I did say I was going to start doing this before I went on the stream, but I can at least leave it kind of running in the background whilst I talk through all of the other aspects of it, basically. So I'm just going to launch the launcher, create the new project, do all the usual shenanigans, and then it will just be a case of every so often I'll off screen like add an extra class, let it load, and then pop back into this. But yeah, so last time I talked quite a lot about how all of this works, why you do these things. I thought I'd just get maybe a more concise version of it. Because I was probably rambling a bit too much last time. So, in essence, the reason you do things like this is because it's extremely easy to see problems before they happen. And that's because the way you think about this part of it compared to sort of the way you think about how it works, what it needs to achieve compared to how it does it. If you spend too much time thinking on how it does it, i.e. actually writing code, you end up, let's think about this. I suppose, so you essentially, you end up in a place where you're focused so much on little odds and ends that come up, and you end up with, I don't know, let's say okay, can't speak. You will be thinking about like how this one particular class works. Like you'll be working on your AI and you go, oh, it should do something like this, and you'll go off and spend maybe like a week working on that class, and then you come to the rest of it. So like you've only worked on this one thing, and maybe you've produced a few odds and ends around it, right? Maybe you've done a couple of bits, but the problem you then have is when you come to figure out all of this, you end up having to go back and changing this again. So you've spent like a week on this thing, and then you come back and all of this is different. Like the way you have to do this in order to make it work for you. So you just spend like hours and hours just producing stuff which it might be good, and with a lot of experience you could almost ignore this entirely. You shouldn't, but you can. But then you end up in a much better place if you come at it from this approach, where you work out what you want it to achieve rather than how it achieves it. I think it's hey, there we go. So this is kind of like I already kind of know what I'm doing with this sort of thing, so I wouldn't have to come up with very detailed descriptions, but realistically we would have actually, let's do this now. So somebody will come, like if I was going to pitch this the game I'm thinking to somebody else, you'd write a much more detailed and description, but it might be missing some things, and it might not be worded very well and stuff. So it'd be like I don't know, it'd be something like, I want a colony sim focuses on, and I do actually want to maybe work more with physics, like realistic physics that I've never done it in the Unreal Engine, so it'd be a good premise to start on that. Oh wow, my spelling, yeah, it is H first. So physics driving the, I don't know, resources and water, etc., right? So I don't know, start with say 5 workers, and that's resources. Build structures. So you can build structures that allow workers to be more effective at their jobs and housing for them, sleep. Ooh. I don't know why it's done that. Interesting. And housing for them to sleep in. So I'm trying to almost purposely be vague with this, right? The idea is you want to be able to go from something like this to all of this, right? Let me just, oh, it's loaded in like that. Oh, save it, close it. Yeah, okay. Oh, hang on. Let me close this. Sorry, I just want to make sure this is running from this so it updates all nicely. Right, so yeah, you build structures that allows workers to be more efficient at their jobs, and housing for them to sleep in. And trying to think if there's any other. You can assign priorities to jobs to give workers focus on tasks. So, alright, terrible spelling, doesn't really matter. Okay, so if somebody literally gave you this, like I don't know, you're you're on the Reddit forums and there's somebody saying, I want a game like this, and usually this is the kind of thing that you get, right? Which is fine. I mean, you got to start somewhere. I mean, this is just kind of what I had in my head. It's just I have the capability of breaking it down into this before I even make a start on these things. So you can immediately see, so we've got, I'll just make this a bit more. So I'm gonna, let's say, I'm gonna color coordinate things. So I don't know, green is a class and blue is an object, right? So the idea of a simulator, actually, let's do this slightly differently here. So like, this is the crux of this entire system, right? We have a simulator. So usually in simulators, before at least, a simulator would be something like a flight simulator or driving, right? And you're actually taking control of it. But when somebody says a colony simulator, it's usually, that implies the perspective that you take when you building it. So like an RTS, you're not realistically in control of the people. I mean, you give them things to do, but specifically a colony simulator compared to an RTS, is you give them the idea of things to do rather than the specific things to do, and they kind of work it out themselves. Whereas an RTS, you give them specific things to do, and they'll have a low level of automated aspects to them. Like they'll, obviously set somebody to gather a tree. They walk up to the tree and they know that they can give it back to the lumber mill or some storage or something. But in a colony simulator, it's exclusively that most of the time, apart from like Stone Half, for instance, is a big one I played. And you could manually control the combat based workers and stuff. So, well, soldiers at that point. And then we have this key aspect here, which I'm just gonna physics, right? So then we have resources. So classes green, let's say. We have the concept of water. We have the idea of workers. Resources again. We have build, which is a doing thing, verb. We have structures, workers again. I'm also gonna throw in another color for like concepts, I guess. Let's go with orange. So there's the effectiveness of things, there's priorities. I'll go back over. We have tasks. We have the idea of a job. We have the idea of housing. Then we have another concept of sleep. Okay, so already you can pick these apart and you say we'll need at some point a class that represents a structure, a resource, water, jobs, a house, tasks, and then we need to include some concepts. So there's this concept of being effective at your job, right? So specific to workers. So this would imply that we need a system for that determines how quickly or how much they get or whatever it entails. This is the kind of thing you'd go back to the person and say specifically how does it make them more effective. And then from this you can very quickly see we've got a lot of classes we can build. And then if you think about like then you can start asking questions like what kind of jobs, what does water do for people, what kind of resources. You've got the idea of housing, and then like what kind of other structures, how do people build things, and all that kind of stuff. You've got this idea of sleep, which implies that workers something can sleep. From context, I would have assumed workers, but maybe not. You don't know until you ask because they haven't been specific. I mean, I've said for them to sleep in, but it could be the case they haven't been specific enough. Anyway, so Rini engine, as you've seen, is just a base star. I went with top down because I mean it's the right perspective to start with, and it gives us clicky things. The end result is obviously we won't be a guy moving around. We'll be a camera controlling people, and you have like a UI at the bottom here, and you click on a building, you say plant that there, and then there'll be like data at the top for your resources and all the usual shenanigans. But it's a good starting point basically because it gives us all of the core classes that we need to be able to do it. Let's get rid of all of that nonsense. You don't need fog. Care about reflection. Like most important. It's easy to just get rid of things that we're not going to use. That's interesting. I'll find out what that's for at some point. I've seen it a few times. I guess it's to set properties. No, anyway, right. So So we've already kind of done a lot of this in here, because I kind of did this backwards, where I did this first before doing this. But hopefully that gives you some kind of idea as to how you break this down. So you've got, in fact, just for clarity's sake, so let's say concepts, entities. Oh, whoops! Come on. So, like actions, and then like I want to say something like implied functions or purpose, maybe. I don't know how else to put that, but it will do for now. Let's call it the key. Right, so there we go. Okay, so we can pick apart these, and if I were to say, I know I could maybe fake some Q&A or something with it, right? But essentially the whole idea here would be to I could fake some responses to the questions I'd ask here, which then would elaborate into this. But you can see how it, going for something like this, could quite quickly build up at least some of these core concepts. And then really, I mean, for me, it's experience that I know I'll probably need to do these things. But you can, every time there's a question you can ask, you kind of need to ask it regardless, right? If you never ask these questions, you start making assumptions, and sometimes you're right, and unfortunately sometimes you know better than the person who's saying what they want, when in reality you know what they need. So I've had examples where somebody says we want something that does, I don't know, displays this information in a different way. So like where people would have, I can't think of what they're called now. You can like rotate columns and rows in a table kind of thing here in Excel, and you just want to see it from a different perspective. And at least on that particular project, we're like, oh, so you want to see this kind of data, but we know we can actually present it better than the way that you're requesting us to. And so we did, and we didn't implement it. We just drew up a literal picture of how it is, and lo and behold, we were right. But sometimes you're not, and it's game over. You somebody comes to you and says we want this or something like this, and you come back to them and they go, oh, I thought you were just gonna add an extra button to this thing, but you've gone and made like a whole separate side system to do something. So, but that's miscommunication, and that happens a lot. But normally you go away, and the best thing to do next is to clarify. So you basically write back what they've asked you to do in the way you would ask it, now knowing what they've said. So you'd like reword things, reorder things, be a bit more specific about stuff. And you'd come back and you say, is this what you actually want? And then maybe they come back with more ideas, and you can do this a bit better. And then, like I've said in here, all of these things, these classes, entities, actions, and stuff, they all come down to this. So, we got this worker AI, workers, the idea of tasks they can perform, and then we've added this, because all this system, because we know in order for these to function, that's what they're going to need. So they don't know about any of this, but we'd maybe hint at it. So I'm gonna start adding C++ classes, and hopefully we're going to be able to at least add the shell of them. So I like doing it from this perspective because it's quite useful. So you just go into C++ classes, colony sim. So we've got a player controller, which will be like what I tend to call an overseer controller. So my RTS game, you're like you're kind of like the god perspective, right? You're looking down on everything and control, giving sort of a more overall commands and stuff. So then what we have is, so if we go into here, so we're going to want something. You can see here that it implements an AI worker from the AI controller. Oh, so we go into here, new class. But we need to go, usually for at least C++, we usually go into all classes because the ones we're actually looking for aren't in existence or accessible in the common classes anyway. So yeah, so you type in AI controller. No, if you were making a proper project, you'd probably separate these into public and private folders and all that stuff. But for simplicity's sake, I'm gonna just leave them all as they are. So this will be worker. It's going to call it worker AI. So all the class will be a worker AI, which sounds quite nice when you talk about it. So yeah, it'll be a worker AI. And as usual, you hit Craig, and this comes up, and you wait, it generates it, faffs around for a minute. I'll probably come up with a, do you want to reload the project? Unless they fixed it, of course. Yeah, you must recompile. There we go. That's going to do it. I thought I hit okay. Okay, let's press the recompile button down here then. In theory, it will appear here. So in a second, once I make sure that this actually functions, I will stop. I'll just do one, let it compile off in the side. But yeah, so for the next one, it's gonna be a character. So we simply want worker. Simple as that. See how quick that is? My god, they've really improved this. That would take, I don't know, like 20-30 seconds usually. So oh, it's failed to generate. It's interesting that this message would appear even knowing that we were the one that created this, and like, yeah, we were aware. So I don't know why they even bother giving you this message, but whatever. I'm wondering if we can create new classes without recompiling, because if so, that would be excellent. So these are structures, and we'll create them inside the context of worker initially, because that's kind of worker and worker AI already have a dependency. So in theory, worker AI should have visibility of these structures, and it should be the only thing that has visibility of these for now. I don't think the actions or tasks care about the statistics of the workers. I think it's the worker AI that generates actions and tasks based on the data. So But that's an assumption I'm making for now, and I'll probably be proven horribly wrong at some point. So, don't know what's the next best thing. Probably like U task and then U action, new event, I guess. So these are going to be based on object, which is U object in this case. You can see at the end the file path there. So whoops, God damn it. Okay, I don't want it to split them into folders because it makes it very hard to navigate quickly when you're searching for stuff. And this is just an example project. So we have task. Now, here's an interesting thing. So we've got a problem here where the concept of task.h and well there is in existence code already called that. So you can imagine this can happen quite frequently, especially when you're using fairly generic names. I would actually be curious to know what task.h already does, but it's probably very specific to the Unreal Engine. Oh yeah, okay. It's what am I thinking of? There's the task job manager. Yes. That's interesting. So there's a whole pre-built in task system, which is cool. But this is like this is clearly something specific for like thread management and stuff, where you create things that occur in an order or whatever, which is what we're trying to create. But we don't want to recreate what they've done because it serves a specific purpose that they've designed them for. In this case, it's a job manager to run gameplay code asynchronously. So you could run multiple repetitive tasks in side by side, at the same time, which is not what our concept of a task will be. So, that in mind, we need to call it something slightly different. And I mean, I could call it my task, but I'm gonna keep it simple. I don't want to overinflate the name of the class because then it gets a bit dicey later. I could call it AI task, I suppose, or worker task. Yeah, okay. So you'll run into this on occasion. When there's if you're working in somebody else's API, which the Unreal Engine is, it's a existing framework. It's very easy to come up with a common name that is already in use. But it looks like it can add things whilst everything else is in existence. It just doesn't update it here. So we're going to do the same again. We want all classes objects. So we're going to make one called action, which I hope good. Action, U object. So you can see in here. So we've got U action inherits from U object, which if I bring it onto here, like before, you can see it adds the inheritance back in, and then obviously if I delete it, it adds it back in there. So in here, this can be U worker task now because we had to change it. We can still refer to them as tasks inside, like for storing and creating them and stuff. We'd be like task equals new U worker task. Yeah, whatever. We'll just let it reload these to keep it in check. We're nearly done anyway. Okay. Fire it back up again. Obviously, these do absolutely nothing. I mean, these are the most generic. They're an object, an empty object inheriting base objects. So, yeah, they have no purpose at the moment. But if we go into the usual. So it's generated all of this, the usual game mode, character, controller, the build files, and we've got our own ones that we've added at the bottom. You can see we've got all the usual shenanigans, setting the cursor, player tick, setting up all the usual inputs, left and right click to going places, and we'll obviously come in and change all of this, but I mean, that's the kind of stuff that I could change in my. What am I going for? I could almost just copy and paste what I did for the real-time strategy game that I did previously. In theory, I should be able to. There'll be a couple of issues with it, but if I was clever about it, I could have made an interface between the controller and my version of the character. And that way, if I was to bring it into this game, it wouldn't be dependent, like the code wouldn't be dependent on the that specific class. And I would just have to make the interface in this project. Anyway, I'll carry on. So we need UEvent, and then a subclass of UEvent, which will be our action state event. And then we've pretty much got everything, because these are enumerations which will be defined inside the class. There's that. That's enumeration. We then just need to make that and the event manager. And then all of these will just be very simple, couple lines of code in the header file of their relevant classes. So we need event, just be lazy. Like that. Calling these same. So same again, new object. Oh, whoops. Interesting. Is this? I guess this. I'm curious as to what that actually generates. I will look into that sometime. Because normally the basic, most primitive thing you want to inherit from is the object. So that's not what I want to do. Event, and here we go again. So event is of course an existing class, because it's such a generic name. So we need to think of something specific to our project. And these are meant to be very generic, so anything should be able to produce events. It's just so far we've only got action state events. So I could call it base event, for instance. It almost doesn't matter. We can change it. It's the important thing. It's a bit of a ball ache to change it, because unless you've got tools like I use, I got ReSharper recently, and it's absolutely insane. It's actually a bit of a issue trying to change the names of files, because you have to change the includes, and Visual Assist isn't very good at that. I'm going to ignore all for now. Come on, you can do it. Okay, that was painful. I don't know if that's loud for you guys, but there's a sound it makes whenever it does that. Anyway, and then what's really cool is you can right click on classes within the C++ and just create a C++ class derived from it, which means you're inheriting from specifically that. So this will be our action state event. and you can see in the header file it's inherited from new base event and includes it. Blah, 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 blah. Right, so that's all the generic stuff. I don't know why I pressed that button. I didn't need to. We need the interface as well, and then the event manager. Cool. Okay, there we go. So now we need to create an interface, which is at the bottom here, which is can't remember how they do it. There's a very particular way. Anyway, you'll see in a minute. This will be our event listener. Yeah, event listener. Okay. So you can see we have the bond. So the main. Yeah. Oh, actually, cancel it. Right. So yeah, it creates a class that inherits from the U interface. And this defines the data. I think, how does it, hang on, it's been such a long time since I've done anything like this. I mean, I did it in my last project, but my last project I didn't realize was like nearly half a year ago or something. It'll be easy to find anyway. Here we go. Oh yeah, so this just exists for the sake of implementing the interface, and then this is where you define the actual components of it. Yeah. Okay, that's cool. So we don't need to do anything here yet, but this will inevitably, under this section here, have the event triggered. Which I mean, okay, just for the sake of it, public. Oh, I don't know why I'm doing this. Void event triggered, and it's going to be the base event. And then this is cool. There. So now you can see we have method, event triggered, U base event. It's same as this. Takes in a U event, which would be which we need to update the name of because to keep it in line. I think, yeah, there you go. You can see it changed the type in there, and as simple as that. So now we have so now we have that. I think that's right, but we can we can obviously faff around with this stuff at some point. But that's pretty much all this needs. That's the point of it, so that we can pass this interface as an array into the event manager, and then the event manager simply iterates over all of its listeners every time it receives an event. So an action or task or work or AI will have a relationship to this, which we haven't built, but in essence, it will probably look something like this, which is kind of why I didn't draw them on here, but look at that. How fun is that? Yeah, this is where it gets a little tricky, but the reason we have this is so these can listen to each other, but indirectly. So an action doesn't actually have any relationship to the task. They don't understand what these are, but they can listen to events that are triggered by the worker saying that I've completed this action in this task, and then they're essentially like listening to all of the events and stuff. So it will always look a bit messy when when I do this, but it's not, it shouldn't be a problem. So the event manager is going to be something. Oh yes, hello. Yeah, I'll be there in a few hours, I think. um, yeah. So I think we've got the crux of that now. Action. Yeah, just the event manager. Um, yeah, sure. That'll be fine. Let's think. So the event manager. Now it could be a. This is the kind of class that I've not had to deal with very often. It's similar to, say, game mode, where it's not quite a static class, but there's like one of them, right? So in my other projects, I have to refer out to the game mode through. Um, I suppose it would be somewhere in here, perhaps. Yeah, game mode. So yeah, as an example, so we're going to have something, an event manager, and it's going to be treated in a similar way to the game mode. So it's going to be a class that always has to exist, and all it does is pass around data. Its literal sole function is for things to say, by the way, this event happened, and then it will just iterate over an array, and it will have an add to the array and remove from the array, or in our case it's register listener and unregister listener. And that way we can listen to things, and we don't have to listen to like I've done in the past, specific types of events that occur, because that causes other problems. So I'm trying to think of what base class we inherit from. So we have a game mode base, but that's obviously specific to making a game mode, which we could use. We could potentially not even create an event manager. We could literally just put this into game mode and then use that, which could be fine. In theory, if we made, say, a generic U object called event manager that did its own thing, the location of where it's stored is the only thing that really matters then, and game mode is as good a place as any that I can think of at the moment. But I've been told in the past that there are singleton classes, so so that's fairly new. Trying to see, because they have. I'm pretty sure I've seen documentation that they've made for it. Let's just look at the forums real quick, because I've asked this question before in the past. Here we go. And there's a snippet example thing here, supposedly. So you have shared static, shared pointer, get objects. If not is valid, make shareable. Okay, I mean that's the kind of thing. Let's try this because I've tried this in the past and I've not been able to get it working before, so I'm going to try it. So we make it based off a view object, and you go event manager. Oh, lo and behold, so we want fucking colony event manager then. Like I said before, that the name just it doesn't matter most of the time. It for context it does, and some people just put random letters or something in front or behind the class names. I mean, Unreal Engine's done it themselves with adding U to things, but of course, yeah, we should be good to stop it this time. But of course, adding it already adds U, so where we would have created just simply event manager, it would have created U event manager. So that was why it was a problem, because U event manager already exists. So I'm actually going to try this. So we have, I'm just going to copy that. I'm going to be super lazy about it. There we go. So this will be this and this. This will be called event manager. So when we come into here, we then obviously we want this. I don't know if this works, but we'll find out. Blah, 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 blah. I'll explain this in a second because I do understand what that is. And does not have not name a value. What are you talking about? So we're in here, we're including it. We have this method of get. We have this method of get here. I'm going to rename this to get instance to be more specific. Okay, so it's fine with that. Make shareable. Wrap object pointers with make shareable to allow them to be implicitly converted to shared pointers. Okay, fair enough. This doesn't seem like this is not the right way to go about this. It's new object. I don't actually need to put static class in there, but it's good to be more specific about it. Have I done this bit wrong? I feel like I've done that wrong. Yeah, that should have been that. There we go. Okay, so to explain this a bit, so the idea of static is that there is only. Oh, one sec. There we go. That was missing. So the idea of a static class or a method is that there is only one of them there, and they when you change the value of the static method, it changes in every instance of that class. So let's say you had an actor for our workers, we accidentally made their health static. Every time that you damage them and change their health, all of the other health values for every worker gets changed. So it's a bad thing for that. But what it's quite useful for is when you're creating data that is useful like once kind of thing. It's something that you set at the start and then it will never change from that moment on. Which you could argue isn't really necessary to put static on those values, but the concept is the same. You have, say you had a value in your AI for like detection range that's like the same throughout all of your classes. Obviously, you put it in your constructor. So, for instance, I've got target range for my AI here. But it's plausible. It wouldn't be a bad idea to set this value to static because I'm never going to change that. And in fact, it could be static const. Right, so this value will never change and it's the same for all instances of this class, which it should be, or at least in the context of this game. But the way we're using this is so that there is a single instance of event manager, so that instead of creating a new event manager every time and then trying to make the events trigger and register listeners and stuff, if we didn't do it like this, they'll never communicate because the array of, so just an example, we'll have a T array of view action, of I event listener. Yeah, that's what we've got. I love that has a spell checker. Come on. It probably doesn't need to be forward declaration because it doesn't really do anything but cause problems. There we go. Yeah, fill out my description, blah blah blah. Right. So this array here would technically be static, but we wouldn't need to make it static. So if we encapsulate this, we had that. So we've now got access to get listeners, set listeners. You probably don't need to use that. And this should return a reference. It actually gets a list. This should be, hang on. Sorry, let me just figure this out again. Again, I've probably got one in here somewhere. Should be an array of something. Surely. Okay, maybe not. Blah 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 blah. I'm pretty sure that's right anyway. It's this is complaining that a non-const reference. Oh, there we go. Yeah, it's not gonna be constant. Right. There we go. So we've got an array getter. So let's say we were in a worker on AI and we got the event manager and it wasn't static. If that's the case, then the this list of listeners would be completely pointless because we would get a new instance of an empty array because it starts uninitialized and we've not added anything to it. So yeah, that's the reason we're doing this. And in essence, if I was to go into the worker AI here, and we go private, I'm just going to do an example method. This will be like void do something, whatever. Let me create the implementation. Okay, so So we got this method called do something, which apparently can be made static. Now what we can do is we can go you what do we call it? Is colony event manager manager equals. That's interesting. Cool. Does that? Oh, I have to click on it. Sorry. So we get that, and then how you access this now is you do this, and you statically access it. So we do get instance. So we now have. So this should be a pointer. So we have this thing called manager, and we're accessing the singular instance. And if I go to this. So event manager will, the first time it's accessed will be null, which the is valid check will come back. Then it will make a new pointer, a shareable pointer, which I've never used before, so I'll look into that as well. We make a new object of the event manager, tell it it's a event manager, and then we run the .get method, which interesting enough returns that. Do we need that? Okay, I guess that's how it works. So instead of, because normally I would have done this, but apparently that's incorrect because this is a shareable pointer, and I guess get is the actual value of it. So yeah, we have event manager.get and job done. In theory. So yeah, from when we're going into the AI, which my god is like miles away. Just close these. There's no way we're working on those anytime soon. Yeah. So we get the instance that returns the single manager, and then as an example, this is quite cool actually. Listener, so we can actually pass in this, and then well, that will do for now. And so if we were to make the worker AI, how do we do this again? It's going to be event listener. Okay, so we get that, and then we go back into here. So the worker, what we're doing here is implementing the event listener interface, which has this event triggered. So we need this in the worker, which I'll explain in greater details another time. Oh, whoops, I've already. Override. This should probably be a public method, I guess. Does that matter? Function does not override a base class member. Should be. Oh, hang on. Let me just check one of my other classes, because I've definitely done this a lot. That will be in my real-time strategy game. Sorry about this. I just thought it was really worth giving an example, because it's not necessarily an easy thing. Oh, so so if I were to close more of this down so I can actually see what I need to. Care about worker task or worker, that's fine. So we override these, they're all virtual things. Makes sense. Is there publicity? Oh, they are public, okay. What was, I mean, Oh, do I have to set them as virtual? I guess that's the problem. Hang on. Event listener. Oh, yeah, of course. Virtual void. Virtual allows you to override the method. In theory, this should go, well, hey, or not. Oh, yeah, it's because we're, hey, see, there we go. Happy now. And this obviously isn't implemented yet. Implementation. So now, we can pass in this. So this method doesn't exist, so we can do that. And it's pretty cool. I mean, obviously, it's assuming the wrong thing. This is actually going to be the event listener. Something like that. Register listener. I don't know if I spelled it right or not. So that's gone and created the method register listener. Close. See, spelling is really important. Just add the e's. So yeah, it's added this register listener public method that takes in a iEvent listener, and then in here, all we would do is the listeners dot add. Oh, come on, listener. Obviously we need to. Oh, I haven't implemented it in the same way where it's like listening to certain events, but in theory, in here we would do something like for iEvent listener L in listeners L dot I dot event triggered, and then we'd have some event, right? So if I where am I looking? What am I looking for? Oh, God, there's too many things on the side. I'm looking for. Oh, I need to copy this. Sorry. All right. Colony event manager. Private. Oh, not private. Public event triggered. Doesn't need to be virtual. Create implementation. So, what are you doing? Good night, idiot. Right. And now, so now let's say, for example, the worker AI, whatever this do something method is, and we go, we need our workers completed their task, and so we create a U action. We made that. We should have made that action state event. U action state event. No, come on. You had it. New object. This is so good. Man, I haven't used ReSharper before, but this is absolute insanity how quickly this is working. Ooh, that's new. I'll look into that. Because that should be working. I wonder why. Okay. Yeah, I'll have to look into this in the future. So now we could go, for instance, manager dot event triggered. Why can't you event? And there we go. So if for whatever reason this method was, so let's say we're already listening. We're already listening to the managers. We're listening to events and it's whatever. So this is when, I don't know, say the worker's dropped off some resources. We can trigger this action state event part, fill in some properties. This will have something like action performed, and it'll be like I don't know, something called last action, and up here we'll have something which will be like a U action. Yeah, and this will be like the last action we performed. It will be like on the private object here. Let me just import that forward declaration. Sorry if I'm going a little quick here, but no, come on. Mouse moves too fast. And then we could say this is the action that we've just performed, and then we could and the action would obviously have its own information in, so it would be a type of like deliver action or something. I can't remember what we've collect possibly. We'll update the value of it, and then we'll say that event's triggered, and then the corresponding action, anything that's listening for that. So for instance, when the building's capable of being built, like I was talking about down here. So if we just completed this collect stone action and the wood one was complete, the action build structure would be listening for these action events, and then it'd be like, that's the event that action I've been waiting for, and then it will set its status and all that kind of stuff. So we'll get in heavily into that soon, but this is just like the bare minimum. This is the least you need to worry about for it. Member function can be made constant. I almost don't care about that kind of stuff. I need to make it stop telling me those things. Anyway, I'll probably there'll probably be something like that in this at some point. I'll leave it for now. I mean, we definitely need the idea of creating actions and stuff. So I guess the only potential issue was where we were registering as a listener. It's interesting that it considers that to be an issue. Not convert value. I wonder how I've done this before. Because in my RTS, so this would be in the base AI, we've only dealt with them as their interface by casting them. I suppose, I guess that's not much of an issue if I just have to cast it, but I can't see why I have to cast it to that in my case, because it is it. I don't know if that makes sense, but in theory it's basically saying I need to oh, hang on, are we passing the interface? Yeah, it's the IIC version of it. Huh, cannot convert. Oh, I'm being such an idiot. Okay, that's my bad. So I made it so this takes in this doesn't isn't a pointer to a listener, so refactor. Oh, what's this do? Oh, okay. I'll learn all of these again at some point. Um so nice. I it's not letting me change. So that's adding all the usual. Um, why can't I add? It's not actually letting me put like the stars. Oh, there we go. Oh, my numlock. It probably doesn't like numlock stuff there. That's pretty cool. So that's changed the signature of that, which it probably hasn't changed it in here. Cool. Okay, I don't know. That's something else to figure out. Um, mm, and this should have been. Oh yeah, duh. Right. Sorry. Return listeners. Yeah. Listeners is a array of pointers to those. Cool. Right. Yeah, I think we've sorted it out now. There. Um. um then there we go. Cool. Sorry for that roundabout. And then in theory, I shouldn't have to do this. Excellent. Right. It was working. I was just missing one very simple thing. So this was taking in a reference to an event listener rather than a pointer, and we only want to deal with pointers in this instance. So. Wonderful. Okay. Pardon me. I mean, in theory, this would function. I mean, I obviously can't make it actually do anything at the moment. I suppose I could make it override begin play. Do I already have one? I was just out of curiosity. Hang on, there's an easier solution. Do we? Oh, we don't actually override begin play in here. It's whatever. On possess is just as good. So as a proof of concept, we do this, implementation. So this is when the this will be when the actor gets possessed by the worker AI, which we can kind of then we can kind of do to this. And so we can see the whole thing kind of coming together. If I put a breakpoint into here and here, and we just need to change the blueprint character to use our worker AI for now. Uh, hmm. Missing public in class declaration. What? Hang on, let me have a look. This is new. Like that because I see. We didn't have public for the event. No. Yeah. And then I'll stop after this. That will be in the event. So this is saying unresolved external symbol event triggered inside the event listener. That's because I haven't actually implemented that method, which I shouldn't need to. I think there's a means of making that possible. I can't remember whether I've even done it before, but if I go to the C++, you can see I've implemented them and they do nothing, which is a bit crappy. There's this concept of pure virtual. So let me pure function. That's a while back. This. Blah 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 blah. Not particularly helpful. Okay. I got one save. So I dealt with this quite a lot. There's that one. Blueprint callables. Hang on, let's go up. Body. So we add virtual. Blah blah blah. Is that blueprint native? That's not what we're looking for. Okay, maybe not that. I'm just kind of looking at random blogs at the moment because I just need this one thing, and I've seen it a fair few times in the past. I don't remember how you're supposed to do it in the Unreal Engine with macros and stuff. Let's just try this a sec. You never know. Blah blah blah. Blueprint pure. That's not what I'm looking for. E function. Again, not what I'm looking for. Damn. Okay. Let's try that. Might be the same thing I just looked at. Nope. Is it? Maybe. Yeah, it's exactly the same. Damn it. Okay, whatever. I'm kind of going. Oh, I'll sort this out another time. Hey, what we do, create an empty implementation and we're done. Sorry for that. It's just if I could find it, it would be nice to have a working example. I'll just let that build in the background, but says that. Let's try this. I've probably already looked at it. Nope. Drive class. Yeah, they all just work with like blueprint callable and stuff. What we're looking for is to not have to define it. Oh, private static unresolved external. this. We need to do this. I think we do this. Okay, right. So yeah, when you're creating using static members, you have to declare them even if they're just null. If they're not declared anywhere at all, then the compiler doesn't know what to do. Right, I really hope I can show you this in practice because it's such a simple structure that we've got, but it does so much for us. So we want to go to the blueprint, top down character, type in AI at the top here, scroll down, is that? Yeah, AI controller class. We want it to be worker AI, compile, save, close, play. Didn't trigger. Let's see what happened, shall we? Have I forgot to put it in the actual oh oh okay. We definitely need to call it super. Why is oh, we lost our breakpoint. That's interesting. I'm gonna recompile the code. I don't know why the breakpoints weren't gonna be hit. It's weird. Still didn't do anything. Okay, I'm just gonna close it. Possess. On possess, override, virtual void. I don't see any other problems, so let's try again. It's weird that it's not. That didn't work. Should have. Intriguing. Did I not save? Oh, wrong thing. Perhaps the change to this didn't influence. Worker AI. I thought that was supposed to browse to it. Okay, fair enough. Worker AI, colony sim, compile, save. Out of morbid curiosity, I'll delete the character, I guess, or oh no, because the character's being generated from the. This is interesting. So usually the character is defined in the game's sort of base settings. It should be game mode. Sorry, there we go. Default form class, top down character. Just there. Oh, okay, whatever. That did the trick. Don't know why the other one didn't. So yeah, now we can get rid of that. Come into here. So, if we go into, we probably don't need that anymore. Let's close some of these. Keep it easy. Cool. So we've come into here. I think I have the call stack somewhere here. So you can see here we got the onPossess, the do something method in here, which interestingly enough didn't hit this breakpoint. I wonder why. In any case, it's registered this as a listener. So if we go into here, you can see we have a listener, which is the AI. And then if we hit continue, I don't know why it went into there. And then what we've done is in here, so you registered to it, created an action state event, ran triggered event. Then we've come into the event manager. And if I go back into here, so we're telling all the other actions that this kind of event is triggered. Now, obviously, this will be sort of handled differently, and you don't want to tell event listeners about themselves, but that's a little tricky. I'm sure they can figure that one out. We'll probably have like an event origin, which will be an event listener, so this can go like, oh, you're the origin, you probably don't need to be told. In any case, so we've got in our listeners, we've got one. It just so happens to be our worker AI that we've just added. And then we go into here, the usual shenanigans. And then lo and behold, because we registered to the event listener, we got past our own action state event. So I need to put in something to stop that from happening, but there you have it. And then it's all there. It's all functional, which is really cool. I'll probably kind of leave it at that, but essentially, we've got the very bare minimum. I really can't stress this enough. This is like the basics. This needs to do not much more, but enough more that it can handle what we need it to. And then obviously, the events need to have some way of not communicating with themselves, so you don't register to your own triggered events. So as an example, the base event will, I don't know, public event listener, call it owner, and then this can, let's probably just straight up include it. And then in event manager, we can go if EI not equal to event. Why did you owner? There we go. So I don't know if that something like that. So I've got an extra one. There we go. Okay, so yeah, so now, for instance, the owner doesn't get told about their own events because that would be silly. And of course, in the AI, we would need to do event dot owner equals this, and we're done. And so now, when this event trigger happens, this won't happen. Just as a quick example, because that was something really simple to implement quickly. And yeah, and this is the kind of stuff where you probably you'd consider these things, but you might not get that from this. You would have to do other kinds of approaches to figure those aspects of it out. You'd probably have to do sequence diagrams where you follow the flow through the system and stuff. But you can see that we've not actually added much more than what we've got here. to make this work. The only difference is we're overriding a basic event just to make this possible, but this would be some method, like this could be build, or it could be collect resources or something, right? And it sets up these other actions and then makes the AI go and do stuff. So we'll need something like this in the future, so it's not completely useless. Obviously, we'll need the event triggered so that we know, so we can listen for when new tasks get put into place, and they might require us to react to them, and all that kind of stuff. And yeah, so we've got the event manager. Okay, we've added this isn't correct, and we've added the event triggered, but it's no different from what its purpose is when it's described in this context. So yeah, and that's why you do stuff like this. So now I don't have to make really complicated things like, this could get really out of hand if you don't think about it. So there you go. And next week I will kind of do a bit of both. So we'll put some design work in here, because most of this stuff was just Unreal Engine specific fancy things that I wouldn't necessarily have to design, like this whole get instance and stuff. That's just whatever. That doesn't matter. It's not impacting the design very much at all. You could account for it and stuff, but basically it just is irrelevant. So yeah, my plan going forwards will then be to actually make this work. They may not actually perform actions, but to put the actions in place so that they can start to do things, moving to places, collecting things, or even just the fact that they assess tasks when they come into here. This method will be possibly very complicated, but good to, we'll go into Word, we'll outline stuff like this, figure out which classes interact with which, when this happens, what happens, and then we'll do a sequence diagram in here, which is if I go into here, you create a use case, which will be, oh no, we didn't add a model. An element? Nope, I'm being an idiot. Diagram then. UML behavioral use case. And then we'll, oh, okay, sorry, it's a sequence diagram, and then this is a diagram of use cases. Anyway, so you have here, and you'll have the user, right? They press a button and it will go off to let's say the AI or the task or something. Trying to find it in the list. Worker task, there we go. So you come into here, and then you can do things like this, and you say this runs event triggered, for instance, and there you can see that and that. It won't actually be like this, obviously. There will be a controller in here in between these, and it will be like left click on the controller, and then it will be like the controller will go determine what happened, and then in this particular use case it could be place a building, and then it goes off into worker task and it runs the create task method, and then the worker task will do lots of internal stuff. So you can run internal operations, and you can say like event triggers, and obviously we don't have these operations, but we can make them from this context. So we don't have to go into this diagram and add methods. You can actually just straight up make them from here, which is really useful. So we never have to, we can just keep going. We just add, there's a method that does this, then this, then this, and then you get an order through all of the systems, how every class interacts with each other. And then this could be like use case for collect wood, and then we create another one for construct a building. And every time you do one, you solidify your understanding of the system and just progressively make it better and better. That'll do. I'm running out of uh, I don't know, oxygen realistically. I'm talking too much. Yeah, cool. I hope whoever's been listening or listens in the future finds it useful in some way. And like I said, our next time we'll do exactly the same as we did before. We'll figure out more of this, and then I'll do a mix of implement some bits of this in here, show you the intended way it will work, like I've done with this, and then we'll go back and do more design, and we'll always try and be like one like design ahead of implementation kind of approach, where I'll try and do the UML of things before we even attempt to implement them, because that's the point. Because unfortunately, a lot of projects do it the reverse, and they'll think they've done all of this and all this stuff, and funnily enough, they haven't, and they make terrible mistakes, and it's very costly. So yeah, I will leave it there and see you guys around.